In this video, we're going to find the exact value of cotangent theta and cosecant theta using the right triangle that we're given on the left-hand side of your screen. So we're interested in finding these trig ratios with respect to theta, which you can see I have marked with red, so everything is going to be from the perspective of that angle. Now, there are a couple of things we need to address before we just go through and plug everything in like we normally would with trig ratios. First of all, you notice on the right-hand side of my screen, all I have is sine theta, cosine theta, and tangent theta. I don't have cotangent or cosecant. So let's talk about how to derive those from sine, cosine, and tangent so it cuts down on all the stuff that you have to memorize. So cotangent theta is the same thing as 1 over tangent theta. So let's go ahead and write that here. Cotangent theta equals 1 over tangent theta. And so that's the same thing as the reciprocal of tangent theta. But we can also see right here that tangent theta is equal to the opposite over the adjacent. So if cotangent is 1 over that, or if it's the reciprocal of that, then we can see that cotangent theta would be equal to the adjacent. So instead of being in the bottom, now with cotangents in the top, over the opposite. So it's just the reciprocal of tangent. So if you memorize your sine, cosine, and tangent, and you just remember which ones are the reciprocals, the reciprocal functions, then it's less you have to memorize. You can kind of derive it as you go. We can do the same thing for cosecant. Cosecant theta is the same thing as 1 over sine theta. And so all we need to do is take sine theta, which is opposite over hypotenuse, and flip it. So that's going to become hypotenuse over opposite. And so personally, I don't memorize them all. I just memorize the 3 and derive everything from that. But it's totally up to you which way, works best for your memory. So that's the first situation that we've worked through, we've solved. The first kind of question mark before we do this problem. We now know what cotangent and cosecant are and how they are defined in terms of opposites and adjacents and hypotenuses. The other thing that we need to address is we have a missing side. But again, this is a right triangle, so we can take advantage of the Pythagorean theorem. So I'm just going to call that missing side x, and we're going to run through the Pythagorean theorem, which will be x squared plus 6 squared. That's the same thing as a squared plus b squared equals c squared, where c is the hypotenuse, equals 11 squared. So x squared, we can't simplify that. 6 squared is going to give us 36, and 11 squared is going to give us 121. And so now we're going to subtract 36 from both sides. Oops. That's going to be x to the 2. So x to the 2 is going to be equal to 85. And then if we take the square root of both sides, we're going to get x is equal to plus or minus the square root of 85. Now, of course, we're going to discard the negative version right there. So our answer is going to be the positive square root of 85. And again, the reason we discard the negative is because we're talking about a length or a distance. And so it wouldn't make sense in the real world for that to be negative. So now that we have the 2 question marks taken care of, let's just go through the process and figure out what the cotangent and the cosecant are. So finally get to the actual problem at hand. So as we found out, cotangent theta is going to be equal to adjacent over opposite. So the adjacent side is going to be the square root of 85. And that's going to be over the opposite side, which the opposite of theta is going to be 6. And there's really nothing we can do to simplify that, so we're going to say that's the square root of 85 divided by 6, and just box it in. Now, if we could simplify the square root of 85, you may want to do that. Like if you could break it 85 into factors, one of which is a perfect square, that's always something to look for in these problems to be sure that you get your answer to match whatever it is you're trying to solve. So now let's do the same thing we did for cotangent, but with cosecant. So cosecant theta, like we found, is going to be equal to the hypotenuse over the opposite. So the hypotenuse here is 11, and then the opposite side from the perspective of theta is going to be 6. So this time we didn't even have to deal with a radical. 11 over 6 does not simplify, so that's just going to be our answer, and box it in. So again, just a couple of things to take away from this. You can either memorize sine, cosine, tangent, secant, cosecant, and cotangent if you want to, or you could just memorize the sine, cosine, and tangent and then remember the reciprocal identities that, for instance, cosecant is 1 over sine, cotangent is 1 over tangent, and secant is 1 over cosine. So it's totally up to you how you do that, but you definitely need to be able to either derive or have all that memorized. And the second thing is, if you're ever dealing with a right triangle and you're missing one of the sides, but you have the other 2 sides, you can solve for that third side, the missing side, using the Pythagorean theorem, and then continue from there.